So far, we know how to find vertical asymptotes, horizontal asymptotes. That's what we talked about last class, right? Let me see. Let's go. Let's just review the whole thing about polynomial. Let's just go to the very back. So polynomial functions and their graphs, right? So standard formula is this, right? We have x raised by n, x raised by n minus 1, so on and so forth. And a couple of polynomials we already know. Constant function is polynomial degree 0. Linear function is polynomial degree 1, because x raised by 1. Quadratic function is polynomial degree 2, because the leading term is x raised by 2. This is a polynomial of degree 7, because the leading term is x raised by 7. Then we talk about the graph, right? With a linear function, of course, we have a straight line. With a constant function, also a horizontal line. Quadratic function, degree 2, right? We either have upward parabola or downward parabola. And if it's degree 2, we have this kind of graph. If the leading term is positive, leading term positive, leading term positive, you see this even degree. Even degree, we have this kind of shape. With, raise your two hands, it's upward W or U shape. This is the degree of even polynomials. Degree of odd polynomials with leading term positive, we have this straight line. Degree 3, we have this. So Jeremy, see, this is the x cube graph. So x raised by 5, we have this little bit fatty. Degree 7, little bit more fatty. Degree 2, this. Degree 2, right? Degree 4, fatty. And degree 6 is even a little bit fatter than this degree 4, so on and so forth. So this is like a trend of polynomials. Then we talk about the transformation of polynomials functions, right? So negative x cubed, so negate this. So the graph becomes here. This is negative x cubed. If we have a negative x squared, right, the graph would be down here. Negative x squared. If a negative x raised by 4, the graph would be down here. Negative x raised by 5 would be here. So basically the y value is being negated. Here's a b. B is x minus 2 raised by 4. So we look at its reference graph, degree 4x raised by 4. Now this is not changing in y value. You see this one, you see c is changing in y value. Right? So x raised by 5 being pushed up 4 units. But here is x value being changed. So x value being pushed to 2 units to the right. So we see this graph, x minus 2 raised by 4. We see every x value being pushed to the right 4 units. Just focus on 0. You see 0, 0, the origin, being pushed 2 units to the right. Okay. Then we talk about the end behavior, right? End behavior of polynomials, this goes forever to the positive infinity. This goes down to the negative infinity. This goes both the way to positive infinity. This goes to positive infinity, go down negative infinity. So this we call end behavior. Okay, so this is a good summarization also. We see this. So we have a polynomial. So this is R degree, even degree. So R degree is like, you raise one hand to the sky, you lower down your other hand to the floor. All right. So your 2 hands pointing opposite ways. And for even degree polynomials, your 2 hands in the same direction. Either both hands raise above or both hands low down to the ground. All right. So remember this trend. odd polynomial, odd degree of polynomial, even degree of polynomial. So with the coefficient, with the leading term positive, if the leading term positive, the odd degree polynomial goes from first, ends up in the third quadrant. Or if it's negative, if the leading term is negative, it goes through the second quadrant to the fourth quadrant. For even degree polynomial, if the leading term is positive, your hands go above your head. If the leading term of even polynomial is negative, your two hands are lower down on your two sides. So this is the trend. So look at this polynomial of degree 4, and the leading term is negative. Leading term is the one with the highest exponent, x raised by 4. So the rest are lower terms. You see this term is 5x raised by 3, then 4x, then minus 7. This we call lower terms. The leading term is a term, the variable has the highest exponent. So this is a fourth degree polynomial. Leading term is negative, so your two hands are lower down. Then in the middle, it depends on the lower terms, you have some wiggles. Okay, so we didn't talk about a zero, how to find the zeros of a polynomial last class. So let's talk about finding zeros of a polynomial, all right, today. So this is a 3.3.2. All right, so 3.2. We didn't talk about how to find the zeros of a polynomial. We will talk about it today. Let's see this example. Let's see example 4, all right? So 3.4, with any functions, we want to graph it, right? We want to graph it. And we know we want to find the x-intercepts, y-intercepts. We analyze the end behavior. And, we see polynomials degree, it was odd degree or even degree. So with quadratic functions, we know how to find zeros, right? We solve quadratic equations. We set the function into 0. But with a higher degree of polynomials, it's a little bit difficult. So what strategy we want to use? We want to factor the function. We want to put the function in the factor form. Put the function in a factor form. Then when we set to 0, it's easy to solve. You see here, this polynomial is in a factor form. It will be easy to find y-intercept, right? So this is already in a factor form. We like to deal with the function in a factor form. Well, let's find its y-intercept, right? So y-intercept first. How do we find a y-intercept? Y-intercept is a p of 0, right? The value, x value is 0. Then we would have 2 times -1. Imagine x is 0. 0 plus 2 is 2. 0 minus 1 is -1. 0 minus 3 is -3. So multiply by -3. Let me put 0 here, maybe at the first step. So 0 plus 2, then 0 minus 1, then 0 minus 3. So let's just substitute x into 0. So now we have 2 times -1 times -3. That would end up to -1 times -3 is a positive 3. 2 times 3, that's a 6. So our y-intercept is a point. It's 0, x value is 0, y value is 6. So this is our y-intercept, right? So y-intercept is a point. X value is 0, y value is 6. Well, let's try to find x-intercept. X-intercept is a little bit troublesome, but with the factor form, it's easier to deal with. So x-intercept, right? We set the function value to be 0. So p of x equals to 0. So we use this. So that means p of x is x plus 2 times x minus 1 times x minus 3. That is 0. Set the function to be 0. Then we use a zero property. Zero property is saying if we have factors multiplying each other to be 0, one of them have to be 0 at least, or all of them can be 0. Either one of them, every one of them can be 0. So we just say, okay, x plus 2 is 0, x minus 1 can be 0, x minus 3 can be 0. So all those are solutions, right? So solve them, we get x equals to negative 2, 1, and 3. So I have 3 x-intercepts. So 3 x-intercepts. I have negative 2, comma 0, I have 1, comma 0, 3, comma 0. Because 3 x-intercepts, right? Now let's see. What's the degree of this polynomial? We have x, we only count the leading term in each parenthesis. So degree would be x times x times x, x cubed. So leading term is x times x times x is x cubed. Okay. We just multiply the leading term in each parenthesis. We have here, we have x here, we have x here. So x times x times x, that's x cubed. That's our leading term. Our leading term is positive and it's a degree 3. So we know the reference graph, right? The reference graph goes through the first quadrant to the third quadrant. We know the reference graph. So we have an idea how to graph this, right? How to graph this. Then now we have y-intercept 0, 6. We have a 3 x-intercepts. So we can graph, approximately, not to be exact, but approximately. We have a negative 2, 1, and 3. We have these 3 zeros or 3 x-intercepts. 0 is just another name for x-intercepts. And we have y-intercept. We have y-intercept 0, 6. We have 0, 6. We have this point as our y-intercept, right? We may not be able to find this point, this point, and this point later on when you learn calculus. So we know how to exactly find those local maximum, local minimum points. But at this point, we know x raised by 3 with leading term positive. It's like, think about your right hand going above to the sky, your left hand going down to the floor. Right? So this is your right hand, this is your left hand. Then draw the y-intercept, then draw 3 x-intercept. Right? You just go from there. It doesn't matter if this lower, this maximum, minimum, these 2 points. These 2 points we won't be able to find at this moment. But it's okay. We don't have to be exact. All right, so that's one way to find zeros for the polynomial or the x-intercepts for the polynomial. If we have a factored form, it's easy to find. We set to 0, then each factor give us a 0. Let's see if we do not have the function in the factored form. So what do we do? Let's see this function. Polynomial degree 3 again. We have x cubed. And we know, the leading term is positive. Again, we have this kind of trend, right? With our right hand going above, going up, going to the sky, our left hand going down to the floor. We have this kind of shape. But let's figure out our y-intercept and x-intercept. Y-intercept is obvious, right? So we plug in 0 for x. If x is 0, we get a y equals 0. So this function, this graph of the function, the graph of this function, go through the origin. Go through the origin, because x is 0, this is 0, x is 0, this is 0, and this is 0. So P of 0 is 0. Now let's find zeros or x-intercepts. Right? To find the zeros are also called x-intercept. It's just another name for it. X-intercept. Right? We want to put in a factor form. So first we factor out x. Once we factor out x, we have x squared minus 2x minus 3. Now we can factor this. So factor as x minus 3, x plus 1. Because the middle term, you see x times x give us the first term. Negative 3 times positive 1 give us this last term. How do we get this middle term? The middle term comes from negative 3 times x, which is negative 3x, then x times 1 from this smiling face, right? Think about this as these two, we multiply these two, right? We multiply x with x, we get the first term. Negative 3 with 1, get the last term. The middle one from this smile. So negative 3 times x, negative 3x, x times 1, positive x, negative 3x plus positive 1x, we get negative 2x. That's how we get the middle term. So now we're in a factor form, so we can solve. So we can put this equal to 0. So if this equals 0, we get 3 solutions. We get x to be 0, x to be 3, x to be negative 1. Because if x is 0, p of x is 0. If x is 3, p of x is 0. If x is negative 1, we plug in here, p of x is 0. So we get 3 x-intercepts. Or 3 zeros, 3 x-intercepts. So 3 x, so x-intercepts, x-intercepts. You get a 0, 0, which is also y-intercept, negative 1, 0, and 3, 0. So we get 3 x-intercepts from those zeros. Now we can sketch the graph, right? Leading term is positive. A degree 3 polynomial goes like this. Then y-intercept 0, 0. X-intercept 0, 0, negative 1, 0, then 3, 0. Then we don't care about these wiggles, this top point, this local maximum point, local minimum point. We don't know how to graph them exactly, but we can, give a approximate shape of this graph. Okay, any questions? Okay, let's keep going, try to find zeros. Let's see this function, negative 2x raised by 4 minus x cubed plus 3x squared. We want to find the zeros of this polynomial, or the x-intercepts. Here we see everyone has x squared in it, right? And also we see the leading term is negative. Well, we know, first, this is a polynomial 4. With the leading term negative, we know the graph looks like this, right? Somehow like this, with the 2 hands lower down. Imagine it's something like an M, right? With think about it, you drop your 2 hands on your side. So it's a downwards M shape, right? X raised by 4. Because it's raised by 4, somewhere you may have wiggles. So let's factor out the negative x squared. So once we factor out negative x squared, we have 2x squared plus x minus 3. Now we can factor this. Okay. So this we can be factored as 2x plus 3, x minus 1. Right? We see the middle term is 3x minus 2x, which is positive x. Right? So solve this, we get x equals 0, x is negative 3 over 2, x equals 1. So we have 3 zeros. Or we have 3 x-intercepts, 0, 0, negative 3 over 2, 0, and 1, 0. What's our y-intercept? Our y-intercept again is 0, 0, which is also x-intercept. Now we can give an approximate graph, right? So degree 4, both hands goes to the same direction, and with coefficient, with the leading term being negative, so both hands go downward. And we have y-intercept 0, 0. We have 2. We have x-intercept negative 3 over 2, 0, and 1, 0. So we can give a sketch of the graph like this. Okay, let's do more. So the factoring part is not so easy. So let's factor this polynomial. Again, it's x raised by 3. It's a degree 3 polynomial. So let's factor this. Well, we have 4 terms, and those 4 terms do not have common factor. So let's group them. Let's group 2 in a group. Put these 2 in a group, put these 2 in a group. So we see x cubed and negative 2x squared has common factor x squared. So once we factor out x squared, we have x minus 2 left. For those 2, we see negative 4 is a common factor. So let's factor out negative 4. Then the first term becomes x. Then a becomes negative 2, because negative 2 times negative 4, that's 8. So we group and factor each group. If you know how to find roots for polynomials, of course, but later on we will talk about long division. Long division, that's another way of finding the roots of polynomials. Of course, yeah, any method if you know how to get it, yeah. But factoring is so important. Factoring is a quick way and easy way. Can you use quadratic? If you can lower down to quadratic, let's see this way, right? This one, you can use quadratic. But quadratic won't work for higher degree anymore. Quadratic only work for degree 2. Because quadratic means degree 2. You see here, once we factor out the negative x squared, the inside becomes quadratic, right? So you can use the quadratic formula for this, for 2x squared plus x minus 3. Inside you can use it. For this one, we won't be able to use quadratic. You see why at this point? At this point, we don't have a common factor. We have to group them. Then now we see we have 2 groups, right? So this group has x minus 2 as a factor. This group has x minus 2 as a factor. Now we can factor out x minus 2. Then we have x squared left for the first term, minus 4 left for the second term. So now you see this function is being factored. It's in a factor form. Then x squared minus 4 is the difference of 2 squares. Can be factored as x plus 2, x minus 2. So we factor as 3 factors. Then we solve. Those 2 factors are the same, x minus 2 squared. So when we solve this, we get 2 roots or zeros or x-intercepts, right? Negative 2 and 2. Now we can sketch. We know x cubed, right? Our right and the coefficient is positive. So our right hand up and left hand down. And then we have those 2 roots. And what's our y-intercept? Y-intercept, right? So p of 0 equals to 8. Our y-intercept is 0, 8. So y-intercept and we have 2 x-intercept. So the roots give us x-intercept, -2, 0, and 2, 0. Now we can graph, right? We know how to graph x cubed, and now we can graph this with y-intercept and x-intercept, right? So y-intercept 0, 8, and our x-intercept of a -2 and 2, and x cubed goes from first quadrant, ends in the third quadrant, and right, could just graph it like this. Oh, why this is not go through this? Because we won't have a 2. So we something called multiplicity. You see, we have 2 roots the same. So -2 is a root with multiplicity of 2. Because we have -2, -2, we have twice. So -2, we have 2 -2 as our roots. So how do we draw the graph? That becomes a tangent point. So the graph goes like this. All right. You see, I mean 2, not -2. Okay, 2, 2, 2, right? We have 2, we have 2, 2, we have 2 2s as our x-intercept. Those two are the same because we have a square. So we just draw the graph like this. Touch the point at 2, then go. But for -2, we only have, there's only one root, -2. So the graph just goes through it. All right, go through it. All right, let's see. Yeah, it's called multiplicity. The word called multiplicity. So this we have 2 of 2 as roots, square. So multiplicity of 2 is 2. Let's look at this. So multiplicity of C. Okay, if the degree is odd, we have this. We have this. Right? If multiplicity is odd, like 2, we only have 1 -2, so the multiplicity is 1. It's odd. It just goes through. It just goes through. If the multiplicity is even, it touches it. It touches it. That's this one. So multiplicity of the root. If the root with odd degree, it goes through. If the root with even degree, it touches. All right, let's see this one. This one is already factored, right? So we have x raised by 4, x minus 2 raised by 3, x plus 1 square. Let's try to find the y-intercept first. Always try to find the y-intercept first. So y-intercept. Y-intercept we just plug in, right? So p of 0 equals to, it's obvious, 0, right? You see x raised by 4. 0 raised by 4. 0 times anything will be 0. So our y-intercept is 0, 0. Well, now let's find our x-intercept. Because it's in a factor form, we can find x-intercept right away also. So 0, 0 is also our x-intercept. The next root is 2. Well, we write 2, 0. Next root is -1, 0. Right? Because 0, if x is 0, the polynomial equals 0. If x is 2, 2 minus 2 is 0. We will get 0. If x equals -1, -1 plus 1 will be 0. So we have 3 x-intercept, 1 y-intercept. Now we can say, okay, what's the degree of the polynomial? Let's figure out the degree. Degree of a polynomial. We have x raised by 4 times this. We have x raised by 3. Right? X raised by 3 times. We only take leading term in each factor. To figure out the degrees by taking leading term in each factor. In this factor, we have x raised by 4. In this factor, we have x raised by 3. You see x raised by 3. In this factor, we have x raised by square. So that equals to x raised by 4 plus 3, 7 plus 2, 9. So this is a degree 9 polynomial. For degree 9 polynomial, again, is odd, right? Odd means and with coefficient positive. Coefficient will have 1 times 1 times 1, coefficient positive. So we have right hand up, left hand down again. So we have this kind of behavior, right? Right hand up, left hand down. Then we have y-intercept, x-intercept. Now we can graph. We can graph. So our right hand is up, our left hand is down, and our y-intercept is 0, 0. Our x-intercept will have 0, 0. We have negative 1, 0. We have 2, 0. You know, in the middle of the wiggles, we don't care. You know, we just draw the wiggles. All right, we don't really care at this moment. What is this lowest point? What is this point? When we learn calculus, we will know how to find those points. Okay, any questions? Local extrema means local maximum, local minimum, like those points. We call this local maximum, local minimum. Because why? Why is it local? Because it's only in the interval, only restricted within an interval. We can call this maximum, we can call this minimum. Because imagine this graph goes on forever, right? This graph goes on forever. So the maximum is infinity, and minimum is negative infinity. So we call those local minimum, local maximum. All right, let's do some exercise for finding zeros. Okay, let's choose a couple from here. So 15 up to 19. You know what, let's choose even numbers. So odd numbers, I will give you some homework for odd numbers. So this would be homework 5. But now let's try. So 16, 18, let's try 20, 20, 22. Okay, let's try those 4 questions. At the same time, I'm going to leave you some homework. So homework 5. Oh, homework 6. Right, you're right. Homework 6. We already give you homework 5. So homework 6 will be 3 point. This is 3.2, right? Yeah, 3.2. 3.2. 15, 17, 19. I'm going to write in the chat, so don't worry about it. For you, try 16, 18, 20, and 22. Try to find the zeros and the x-intercepts, the y-intercepts, and the degree of the polynomial. Then try to sketch the graph. 15, 17, 19. Factor the polynomial, use factor form to find the zeros. Okay, let's try some in 27 also. 27 to 40. So if you could try 28, try this 4. Try these even numbers. Try this 4 now. I'm going to leave you 27, 29, 31, 33, 35 as homework. 38. 1, 2, 3, 4, 5, 6, 7, 8. 36. 37, 37, 38. All right. Okay, let us try 16, 18, 20, 22 for now. You know what? We don't have that much time. Let's just try 2 of them. Let's try 16, 18, 28, and 30. All right. Let's try those 4 questions. Sure. Yeah, but I'll try 4 questions. All right. Then we choose one to show it. Right, let's give a couple more minutes. Try all 4 questions, all right? I put a link of about finding zeros of a polynomial under the content. Yeah, might be a good idea to watch it. You know, YouTube has so many good stuff. All right, so in 4 minutes, let's show it. So Tijeda wants to try 16. And any of you want to try the other 3 numbers? Right in the chat. Okay, Rena wants to try 18. Maybe 2 more people. So 16, 18 are claimed. Have 28 and 30. To be able to factor expression is a very important skill. All right. Okay, so Tijeta, we start with you, 16, then Rena, 18. And if anybody wants to show 28, 30, that would be wonderful.
I'm doing the graph right now. If Rena can go first, if that's okay.
Sure. Rena, you ready? Right, if any of you ready. Right. Okay, great. Thank you.
So for 18, I found the x-intercept. Like I set them all to 0, and then the x-intercepts are half, comma 0, and then -1, comma 0, and then -3, comma 0. Then I found the y-intercept. I plugged in 0, and then multiplied, and then I ended up with 0, comma -3. And then the leading coefficient was x squared. So then it's like negative and then positive at the end. So I did the multiplicity thing, like they all have a 1. So then they all go through, and then I ended up with this graph.
Beautiful. Very nice. Yes. Thank you. We don't care about this top points, this point yet. Great. Thank you very much. Anybody has any question? Great. Great job. Okay, well, we're waiting for Tijeta. Since nobody like 28 and 30, so let's talk about 28 and 30. Okay, let's see. Anyone? Yeah, I would like you guys try. Oh, Tijeta is ready. Okay, go ahead.
Professor, my name is.
Oh, how do I see your name right?
Sorry, it's Tigida.
Oh, Tigida. Beautiful
Yes.
name.
Thank
Okay.
you.
Tigida.
You didn't make me as a presenter yet.
Oh no, sorry.
Nah. Okay.
That's right. Okay, now you are.
So for question 16, it's P of x equal x minus 1, x plus 1, and x minus 2. So what I did, I try to find the y-intercept first. I plug in 0 for every x value, and I ended up getting x equals 2. I mean y equals 2. So the y-intercept is 0, comma 2. And then for the x-intercept, since it's already in this form, I just equals p of x equals 0, and then everything else inside is of course equal to 0, and then I solve for x. For this one, I got x equals 1, x minus 1, and x equals 2. So my zeros for the x-intercepts are 1 0, -1 0, and 2 0. And the graph doesn't look too good. I tried to connect the dots, but it didn't come out good. I tried. But it's polynomial of degree 3, because how I find out is I did 3 times, I mean x times x is x to the third.
Great.
Yeah.
Then remember the x cube graph?
Yes, I try to
use
go
your
back
right
to
hand.
the textbook and find it, like the shape of it.
Can you do this? Raise your right hand to the sky and lower
Uh-huh.
your left hand to the floor.
like this.
That's the shape, right? So this
Yeah.
one on the right, so this one, you probably don't see my pointer, should be up, should shoot up to the sky, right? Because it's degree 3.
I mean, I can see the points because I'm presenting, I guess.
Right, you cannot see my point. But in the first
Yeah.
quadrant, you see your first quadrant graph going downward.
Yeah.
That
Yeah, it's
won't be
supposed to be
correct.
going up.
Yes. That's the
Okay, I
only,
got it.
that's the only thing.
Okay.
Okay. Okay, great.
All right.
And
Okay.
yeah, you get the gist of it. That's great.
Yeah.
All right. Anybody has any question? All right. So let's talk about 28. The what do you call it? Factoring. Okay, factoring is such important skill. Let's talk about 28. Going to calculus, we need to know how to factor stuff, how to put an expression in a factor form. So let's look at 28 first. So I have this cube, so you see every term has x in it, right? So let's factor out x. So p of x, let's factor out x first. So then the first term becomes x squared, the second term becomes 2x, the third term becomes -8, right? I can pull x out from every term. Then the first term x cubed becomes x squared. The second term 2x squared becomes 2x. The third term -8x becomes -8 because I pulled one x out. Now, can we factor this inside? You may use quadratic formula for the inside, or you can factor like this. X plus 4x minus 2. You may ask me, how did I get that? Think about it. The factor of -8, right? How do we play with the factor of -8 to, to add the two factors to get 2? So the process is like this. Think 2 factors of -8 and that adds up to +2. So think 2 factors of -8. Of course, there are many, right? There are many. Let's make a list of factors of -8. 2 numbers. So -8 equals to -1 times +a equals to +1 times -8. But none of them. And now those two factors, when we add up, we'll get +7, -7. We won't get +2. So then we can think about +2 times -4, right? +2 times -4 is still -8. Or -2 times +4, right? So -a, I can think of 2 factors, -1 times +a, +1 times -a, +2 times -4, or -2 times +4. And which 2 factors add up to be +2? Because there's a middle term. I need to consider, how do I get middle term? The middle term +2 I getting from adding the 2 factors, right? Why is that? Because the middle 2, you see here we have 4x, then we have -2x, right? 4x plus -2x give us +2x. So add the 2 factors, whichever gives me +2. That's the factor I need. So here, +2 minus 4, that's -2. If here I have -2x, I would choose this pair. But since I have +2 there, so I have to choose this pair. Because this pair gives me +2. -2, +4, I add up those two, I get a +2x. So that's why I know I can factor as this, x times x plus 4 times x minus 2. Once we're in a factor form, we can set to 0 to solve. So we have 3 zeros, right? 0, -4, and +2. All right, let's see the next one. See 30. Any questions for this? Let's see 30. So 30, let me see, maybe I read here. So P of x, what do? I don't like, okay, first I see everybody has x, right, term. And I don't like the leading term to be negative. So let me factor out negative x. So I factor out x, then the first term becomes 2x squared, right? The negative x times 2x squared is negative 2x cubed. Then plus x, negative x squared, I factor out negative x, I have x left. Then minus 1, right? I factor out negative x. So negative x times negative 1 still give me positive x. So I just rewrite this expression, this function, into this form. I factor out the negative x. Now, maybe I can factor out what's in the parentheses. So negative x is one of my factors. Now, let me factor the inside. The inside I can factor as a 2x minus 1 and x plus 1. You may ask me, how did I factor that? Because I'm thinking how to get the middle term. How do I get the middle term? I multiply, oops. I multiply again this smiling face, right? You see 2x times 1, positive 2x. Negative 1 times x, negative x. 2x minus x, I get positive x. I get a positive, because here I get a positive x, positive 1x. So I know how to factor this. Then I set this one equal to 0. That gives me roots or zeros, 0, x is 0, half, negative 1. All right, that's how we factor. Okay, anybody has any questions? Okay, some of you are able to submit your homework, but you really have to show, you have to present your homework, all right? So to make sure the homework is done by yourself. All right, so that's about today. So today we're trying to find zeros of polynomials by putting in a factor form. So practice your factoring skill. So I may find some YouTube videos about talking about factoring. Okay, anybody has any questions? Okay, if not, yes. Where are you going to post this recording? It's under the content. Let me show you. It's under the content. Let me see if I can go through this. You see this content, right? After you go to the classroom, you see the content. Under the content, we have syllabus, textbook. Oops, you don't see here. Do you see it? Content right here. Okay. So content, so syllabus, textbook, homework 1, homework 2, homework and presentation, functions. So those are YouTube videos about functions. and the domain functions, transformation functions, inverse functions, compositional functions, homework 2, homework 3, polynomial functions, quadratic functions, homework 4, rational functions, homework 5, homework 6. Homework 6 is for today. Then I just load find zeros of a polynomial. I may try to find how to factor expressions. So we need to learn how to factor expressions. I may find a YouTube video for that too. Okay, anybody, any other questions? YouTube is such a good resource, all right? Okay, if not, I see you, if not, if no questions, I'll see you next Wednesday, right? Right. Okay, do you know where to find the recordings? This is how you find the recordings. Before you get into the classroom, let me share this with you again. So you go to Collaborate Ultra, right? So this is loading. Before you click on course room, you see these 3 bars, menu. The recordings are here. All the recordings. Okay, any other questions? Okay. All right, have a good weekend and see you next Wednesday then. Take care.